Hello students, today I am going to have my lecture on the dual nature of matter particles. We said in our previous lecture that matter waves are there. Means particle matters like electron, neutron or proton can be have like a waves, but we are aware that the two important characteristics of the wave are interference and diffraction. So when this invention, these things were in the process of development, the scientists were discussing that how to prove that matter behaves like a wave, and in this regard Davisson Germer experiment came, which actually shows about the wave nature of the matter particle. So let us consider, and this experiment was done in 1927 at United States. So in this experiment there is an electron beam producer and it is produced thermally, and then there is an accelerator, okay, which accelerates these electrons electrically, and then there are two slits which actually used to refine. This whole arrangement will be called electron gun, this whole arrangement, okay. And when the electron gun produce electrons, they are attacked on a target which is seen nickel and is of the characteristics of single crystal types. Now all of this experiment is carried out in the vacuum. Once the electron is incident on the target of nickel, a Faraday chamber, or it is also called Faraday cup. A Faraday chamber is used to measure the contact number of electrons, okay, and this chamber usually keep on moving, okay. So it takes the reading from one position to another and gives us a graph. So once this arrangement is done, production of the electron, isolation of the electron, then selection of the electron from the slit 1 and slit 2, and then the targeting of the electron on the nickel crystal. A beam of low voltage electron was made to fall nickel target, which was measured after reflection by the Faraday chamber and electrometer. This is electrometer. The observation is repeated with the increasing in the voltage. Okay, for the 40 volt, a smooth curve is obtained. If you are counting at the 40 volt, you are taking, then this type of curve will be coming. At 44 and 48 voltage, which is shown here, a bump is observed. Starting of the bump production is happening. Now at 54 volt, this 54 volt is oscillating voltage. 54 volt bump is maximum. See here, and then the bump. And if I am increasing the oscillating voltage further, then the bump is gradually start again decreasing. Means the maximum bump is observed at the 54 volt and at the angle of 50 degree from the for the measurement. So this experiment was carried, but experiment itself do not say anything. Now using this experiment, we are aware about the Bragg's equation, which says 2t sin theta is equal to n lambda. Considering n, we calculated the value of lambda, and we know the angle here is 50 degree, so sin 50 degree, and we know about the nickel crystal, this nickel crystal lattice, and which is about 2.15 angstrom. So 2 into 2.15 angstrom into sin 50, the lambda value comes out to be 1.65 angstrom. Now again, to re-verify this, we use de Broglie hypothesis, which says lambda is equal to h upon mv, h upon root over 2m electron volt, electric volt, and when we put all the value of mass of the electron and the charge of the electron and the oscillating voltage 54, we comes again at the value of 1.66 ampere. Thus, from the Black's equation and from the de Broglie hypothesis, we have seen they are giving me the same value of lambda. Thus, this shows that the Davisson-Germer experiment is able to prove that electrons are behaving like a wave, and the wavelength of those electrons was 1.66 angstrom in that experiment at 54 volt. It shows me the dual nature of the matter particles, means they are matter as well as wave. Thank you for listening lecture.